everybody, this is Mrs. Anderson, and today we're working on Master Math Mentor, Section 4, the graphical approach to limits. And this is going to be combined classwork and notes together because we should be able to get it done pretty easily. So if we look at this graph to the right over here, this is going to be the function x cubed minus 8 over x minus 2. And so it says for all values of x not equal to 2, you can, for all values of x not equal to 2. So why does that happen? Of course, because if we do 2 minus 2, we get 0. And our denominator cannot equal 0. But the function is not defined at x equals 2, and there's a hole. Now, some of you maybe think, well, why isn't there a vertical asymptote there instead? Because that's what happens when the denominator is 0. But I want us to remember here SOAP. Okay, so this is how you factor x cubed minus 8. Same sign, x minus 2. Okay, so you cube root the x, cube root the 8, x squared, so opposite sign is plus, and then we're going to multiply these two together. And then we square the end, and it's same side, sign, opposite sign, always positive. So here's our plus 4. Okay, so that's how we are going to do that. Okay, so now, I hate to say I jumped off to make sure I did not tell you right. It's been a long summer. Okay, so this is correct. Okay, again, cube root the first term, cube root the second term. Square the first, multiply together, square the last. Same side as the beginning, opposite sign, always positive. Okay, because that's the top, and now this is the bottom, we're allowed to cross those guys out, and that's what's going to create that hole. Okay, so remember, a hole is when we're going to cross out something on our top and our bottom. So now, if I were to take 1.75, set the calculator to 4 decimals, I'm going to fill in this chart, and just for time's sake, I'm going to set it up for you. Usually I don't have you guys write in our zeros at the end, but that's fine if you do. And if you don't, that's okay too. Remember, we're going to have an error here because we have a hole. And we get 12.0060, 12.0601, 12.6100, and 15.25. Very large jump there. Okay. And it should be obvious that as x is getting closer to 2, that we're becoming more like 12. So let's look at this. As I'm walking towards 2, okay, and this is going to be called 2 from the left, that number is kind of getting to 12. And if I come from the right side and I'm walking there, and this is called 12 to the right, then 2 to the right, excuse me, if I'm going 2 to the right, you can see again that number is virtually 12. And this is what's called a limit, is as we approach from the left and the right, we're getting closer to the same value. So down here, it kind of boxes out, the limit of f of x as x approaches some value of c from the left side. This is called the left-hand limit. And you'll notice here We have c with a negative just past it, means left side. Then we're going to find the limit of f of x as x approaches some value of c from the right side, which means the right limit, that's the plus. And in order for a limit to exist, the limit on the left has to equal the limit on the right. And this is then just a value. So your options are a value or does not exist. Okay? And it's important to understand that x going to c and f of c do not have to equal each other. And remember that f of c means the y value. This is where a lot of you are going to get confused. The limit of that function, and this is the y value at that x function. So remember to read it as y value. Kind of do that translation in your head. Okay, so let's talk about this. So let's look at example 1. The limit as 1 as we're walking from the left side. Okay, so here's my 1. I'm just kind of making a little dotted line. And I'm walking up the hill. And as I'm walking, I'm getting closer to 1. And now, I'm walking from the right side. And I'm getting closer to 2. Now, these two things do not equal each other. And we saw from up here that the left and the right have to equal. So in this case, this does not exist. But here, it says, what's the value at 1? Well, the value at 1 is where the solid dot is, and that's 2. And so I'm going to write here, solid dot. So what does this look like in the real world? Well, this looks like GPS. This looks like you put something into an unupdated thing in your car, and you and your buddy are meeting at Taco Bell. And here's Rachel. Rachel is driving to Taco Bell, but Megan, her car did not update correctly, and so she's driving to the old Taco Bell that's now been torn down. So it's all empty there. They're at 2 different places. They're not going to be able to eat together because they're not in the same place. So kind of think of limits as approaching a place that you and your friend are trying to get to from different directions. So let's look at this guy. When I'm coming at 1 from the left, so again, I'm going to just draw a little dotted line here so I can kind of keep track. It's super light. I'm walking along the road, and I get -1. I'm walking up the hill, and I get to 1. Again, this is the right side. This means the left side of that value. Well, again, these two numbers don't equal each other, so this does not exist. But the value of 1 is the y value. So at 1, what's the y? Well, it's 0. Now, when all of them have to equal each other, that's going to be continuity, and we're going to talk about that later. But right now, we're just talking about limits and comparing what happens at the left and the right. So let's move on. Example 3. As I come from, and if this is helping you guys, definitely put this dotted line in. Sometimes it helps me, I just get a little sidetracked. So I'm coming from the left side, I get 1. I'm coming from the right side, I get 1. So I'm at Taco Bell, me and my friend, we're both there. So I can say, we're at Taco Bell. Now, please don't write that as your answer, just put 1, okay? But in our real world situation, that's what happens. Now it says, hey, what is the solid dot at f of 1? When our x value is 1, do we have a solid dot? No, we do not. So that does not exist. Coming over here, 1 from the left, 1 from the right. So I have a limit, and this time I actually have a y value at 1. So when I look at 1, I come down and my solid dot is at -2. All right, so now we're going to start talking about some asymptote issues that are going to appear. When there is a vertical asymptote at x equals c, so remember c just means the number I'm giving you, then the limit does not exist. Okay, so we're going to underline that. If the function is going up, approaching the vertical asymptote, we're going to say it's infinity, which is saying there's no limit. And if the function is going down, we're going to call it negative infinity. Now, I'm going to kind of change it up a little bit differently, and then we're going to write does not exist in all of these cases, but give reason. This is something that really confused me last year. Sometimes you're going to see it, if you do see it as going to infinity, and they're both going that direction, that's fine. But what I'd like you to be writing is does not exist. You will never be given a situation on a test where these are both the correct answer. Okay? So, as I'm approaching 0 from the left side, okay, so I'm right here. I'm approaching 1. 0 from the right side, 1. So the value is 1, and I'm just looking at these two now. I look at f of 0, and I see 1. So a little bit different picture this time, but still okay. So this is now before we start talking about asymptotes, and now we're jumping into asymptotes. So even though this one doesn't look like it's continuing, there's no asymptote involved in him. Remember, our asymptotes are going to be shown with these dotted lines. So as I'm approaching 2 from the left side, I'm going to get negative infinity. As I'm approaching 2 from the right side, I'm going to get positive infinity. And the limit does not exist. And I'm just going to write underneath negative infinity, and I'll do an and sign, positive infinity. Now f of 2 definitely does not exist. You can see that there's no solid dot. It's an asymptote. Okay. Now, over here, when I go 2 from the left side, so negative 2 from the left side, I'm doing negative infinity. When I do negative 2 from the right side, I have negative infinity. So what's the limit? So what I'd like you to write here is does not exist. And underneath, I'm going to say because of negative infinity. So in this case, they both equal negative infinity, but we either have a value or we have does not exist. Infinity is not a number. Okay, it's a very abstract thought. It just goes forever. And again, what is the value of y at negative 2? Well, that's 0. Okay, so we're on our last portion of notes here. So starting at the top, we also are interested in the limit of a function as x approaches positive or negative infinity. So remember, this means on my graph, I'm headed out with my x's as I go out to the right or out to the left. And sometimes it's hard to forget. I keep wanting to go up and down, but that's not the case. This answers the question, what happens to y as x gets infinitely farther to the right or left? And for these terminologies, we're going to use this. The limit as x approaches infinity of f of x, or limit of x goes to negative infinity. Okay? So let's talk about these examples. There's going to be 5 possibilities of what could happen. There are only 5 possibilities of when we're going to the right or left to infinity. The curve can go up forever. In this case, the limit does not exist. For convenience's sake, we say that the limit as x goes to infinity is infinity. So in this case, again, we can put, as I'm going out this direction, I keep getting higher. It does not exist. And again, I'm going to write because of negative infinity. And when I'm going out to the right, I'm going out and out and out. I'm going up and up and up forever. Again, it does not exist, and underneath I'm going to write because of positive infinity. Okay. The curve can go down forever. Again, in that case, the limit does not exist. But I don't want us to right now worry about for convenience's sake. I really want to now stick with the does not exist idea. So we're going to turn what they kind of like us to write into the reason why not. Okay? So as I go out to negative infinity, I'm going up forever. Well, that does not exist. Well, why? Because it's going to positive infinity. I'm headed down forever, this direction. Again, that does not exist because it's heading towards a negative infinity. Now, these are issues where we have a horizontal asymptote, and the horizontal asymptote is always going to be a little bit different. So the curve can become asymptotic to a line. In this case, the limit is a value, and it's the value of the asymptote, okay, because it's going to keep getting closer and closer to that y value. So in this case, as I'm going out to negative infinity, I'm getting closer and closer to that positive 4. And as I'm coming out farther and farther to the right, I'm approaching negative 2. This way, I have it oscillating. Okay, that's what an oscillation is, back and forth. And it's starting to approach a final value, which is 1. Whereas this guy is approaching 0. And then our last example on this guy is the curve is going to oscillate, but it never gets closer. So I'm going up and up, and you can see that it's the same height every time. So this is going to be does not exist. And because it's not consistent to an infinity, I can't give that as the reason below. It's either up to 4 or down to negative 4, so there's nothing. I just literally does not exist. Now this guy is getting higher and higher and higher and higher, so we can say it does not exist, and then underneath I can write because of, or I can write positive infinity. And those are our notes on graphical limits. Best of luck!